In this lesson, 2.10 point B, we are going to be analyzing quadratics in context. So our objective is to use your knowledge of quadratics to solve problems. Specifically, you're going to be using what you learned last lesson to build quadratics given a contextual situation. So for example, in this picture here, we have a baseball. And when you throw a baseball, it goes up, it reaches a maximum height, and then it goes down. The motion that the baseball follows is actually a quadratic. It makes a parabola. So we use parabolas or quadratics to model motion. We can also use quadratics to model shapes. Many things are in the shape of an arch, and that's what we're going to be doing today. So here's an example of motion. So you can see the guy behind this graph, and he is throwing a baseball. What I can do is we'll lighten up this graph a little bit more so you can really see what he's doing. So you can see that he is throwing a baseball, and like we talked about with motion, it's going to form a parabola. So it's going to be upside down. It's going to go up and it's going to go down. So one thing I know is that this parabola is going to have a maximum point up here, somewhere about here, and it's going to be opening down. So let's bring our graph back. And let's try to build an equation from what he is doing. So let's first make some points. Let's see. Go ahead and use blue. So it looks to me like his maximum is going to be about right here. And then he is going to come down into this hoop over here. So if I know that he is standing approximately 10 feet right here from the hoop, and I've put this graph in place, I can build an equation. So think about what we know. We know the vertex, so we know our HK. Our vertex is 5, 7. And then we can pick a point. We can pick any point we want that is on this graph. And we're going to just pick an approximate point. So if I follow along, let's see. It looks like maybe I'll choose this point. It's approximately at 1, 5. And I may be off a tiny little bit, but it'll be close enough to build an equation. So we'll say that the ball hits or passes through this point 1, 5. Now I have enough information to build my quadratic equation in vertex form. So we know that in vertex it is y equals a parentheses x minus h squared plus k. So the squared means I do have a quadratic, a parabola. Remember that a is my rate of change, and then h and k are my vertex. So let's go ahead and build our equation. So we've got y equals, I don't know what a is, I'm going to have to find that, x minus, and this is my 5, which is positive, so it should be a minus 5. It's always the opposite, plus 7. Okay, now I can plug in my point for x and y. 5 will go in place of y. I don't know a yet. 1 will go and replace x. And now I'm in a position where I can simplify this. So I will have 5 equals a. 1 minus 5 is negative 4. I'm going to square that, plus 7. Simplifying that a little bit more, negative 4 squared is positive 16 because negative times negative is a positive, and then plus 7. I'll go ahead and subtract 7 from both sides, and I will end up with a negative 2 equals 16a. So my final step will be to divide both sides by 16. And 16 and 16 give us 1. So my a term, and I'm going to reduce this, negative 2/16 reduces to negative 1/8. Notice that my rate of change is negative, which is what I want because my parabola is going to open down. So when I write the final equation of my parabola, I will have y equals negative 1/8 x minus 5 plus 7. And that's the equation of this parabola. It models this contextual scenario. Okay, let's try a couple more. Let's look at the arch in St. Louis. So I know that this arch is approximately 50 feet wide. Okay, and so I've put a graph on top of it and I've started it here at 0, and we have 50 right here. So I know that it is 50 feet, it spans. And so I just want to build an equation to represent this arch. Well, if I look here at my vertex, again, I'm going to have a maximum, and it looks like, and if these go by, this is 30, so this is probably 25, it looks like right here. Let's go by 5s. So that's 25 and that's 600. So it looks like my vertex is going to be at 25, 600. So the arch is about 600 feet tall. So let's build our equation. We have a vertex and we need a point. I could actually use this point here, but maybe I'll just go ahead and I'll pick up a different point. How about, let's just try right here. So if this is 10, then this is about 4, looks like it's going by 25s, 425, 450. Oh, nope, not the case. It's going by 50s. 450, 500, 550. So this is going to be 450. So the point that I chose is at 10, 450. So I chose any point on this arch. You can choose any point you like. You just need to make sure that you label it so that I can see it when you're doing your practice. So this is my vertex, and this is my point. So let's go ahead and build our equation. And I'm going to combine all this into one step. So I know what a y is. I have 450 for my y. And that is going to equal a, which I do not know. For my x, I have a 10. And then my vertex is 25, so that's minus 25 squared plus 600. Okay, simplifying that, we'll do the parentheses. 10 minus 25 is negative 15 plus 60. Okay, and I left off a 0 here, so let's put that back on. And hang on, gotta get the right color going. Okay, so it's 600. Okay, so we'll go ahead and do our exponents. Negative 15 squared is positive 225 plus the 600. Then if I go ahead and subtract 600 from both sides, I should get a negative 150 here and 225 times a on this side. These are gone. Okay, my final step will be to divide both sides by 225 in order to figure out my rate of change. And notice I am going to get a negative rate of change, which is exactly what I needed. So what I get is a is equal to negative 150 divided by 225. Now a couple of things I can do. This is a very big fraction. I could reduce it. I can see right now that 25 goes into both of these, so I could do 25 into 150 and get 6. I could do 25 into 225 and get 9. And then I could reduce it further. 3 goes into 6 2 times, and 3 goes into 9 3 times. So that is one thing I can do. I can also put it in a calculator if I want to, and I can go ahead and do that right now. So let's see, we've got 150 divided by 225, and I should get 0.6667. So I could use that as my rate of change if I wanted to. Either way, so just make sure you reduce it or you divide it out so that you have a rate of change that's more understandable. So our final equation is going to be y equals, and I'll go ahead and leave this as 2/3. So we have 2/3, and it's negative, by the way. Can't forget that it's negative because of this negative right here. And we can look at our arch and see that it opens down, so our a value does have to be negative. And then it's going to be x minus 25 squared plus 600. Okay, and that's how we build equations given contextual scenarios. And that concludes our lesson today on finding a quadratic equation that models scenarios.